The last section before the test is on the binomial distribution. It's the hardest section on the test. So the general formula that we're working with is n, the number of possible trials that you're going to be doing. NCR, a key that you need to find on your calculator. I'll go over that more in a second. X, the number of successes we're looking for. Times P, the probability of success, to the power of X, the number of successes you want. Times 1 minus P, or the probability of failure, to the power of N minus X, or the number of failures you'll have. So the key things that we need to know are, how many times are you going to run the experiment? How often are you trying to be successful? And what's the probability of success on any given trial of the experiment? If we're given those three things, we can plug everything else into the formula. We could solve for 1 minus P using P, which would make this slightly easier, just like we could solve for N minus X and plug those in. That would make it slightly easier to put in our calculator. It's really whatever works best for you, but it is going to be somewhat tedious entering everything in to get some answers, especially for questions like these at the bottom that have more than one iteration of the formula. But starting at the start, we're looking at number 1. We have 3 trials where the probability of success is 0.7. We're trying to find what's the probability you're successful exactly 1 time. So following the formula, we're going to set up N, which is 3. Then we're going to press the NCR key. Then we're going to do 1, the number of successes, times the probability of success, 0.7, to the power of successes, in this case 1, times 1 minus that 0.7, to the power of the number of trials, 3, minus successes, 1. If I put that all into my calculator properly, I'm going to start by pushing parentheses, then I'm going to push the 3. The next button is the one that's tricky that you probably haven't used before. On my calculator, which is a TI-80 whatever, if you have any of these that's a graphing calculator, you're going to press this math button. After you press the math button, there's 4 columns. You go to the 4th column marked PRB. So I use my cursor to move to the right to PRB. Under PRB, the 3rd choice is NCR. I move the cursor down to number 3, press enter, and it shows up here in my line that I'm trying to type. In most other calculators that are smaller, like the TI-30, there's a specific PRB button. PRB is short for probability. When you press the PRB button on the TI-30, it gives you a choice to scroll between of either the exclamation point, NPR, or NCR. NCR is a choose function. What you really need to know about it is that it basically accounts for all the different ways the successes could happen. So if I have 1 success out of 3 trials, it could be the first one successful, it could be the second one, it could be the third one. There's 3 different ways to arrange this. That's what this takes care of. How many different ways are there to arrange this many successes and this many failures? So again, it's very important you find where this button is on your calculator. It's possible your calculator doesn't have it, in which case you're going to need to find one that does, either on the internet, from an app you download on your phone, or from buying a new calculator. But in general, I recommend, if you have this one, definitely use it. It's great. The TI-30X is the one that has this PRB button we use, that in general I tell students to get if they haven't gotten a calculator at the start of the year. If we put this all in correctly, we continue by putting the 1 after the NCR in parentheses, 0.7 to the power of 1, end parentheses, new parentheses, parentheses, 1 minus 0.7, end parentheses, to the power of new parentheses, 3 minus 1, end parentheses, end parentheses. When all that's put in right, I get a probability of 0.189. Setting up the second one, same idea. I look for N, it's 10. I'm going to press the NCR key. Then X is 8. The probability of success is 0.6. I'm going to take that to the power of 8. Then I'm going to do 1 minus that 0.6 to the power of 10 minus 8. If I put that all into my calculator correctly, parentheses 10, NCR 8, parentheses 0.6 to the power of 8. Note that some calculators, when you go to the power of, go into an exponent line, where after you press that 8 in the exponent, you want to move your cursor to the right to get out of exponent mode. I then want to do parentheses, 1 minus 0.6, and parentheses to the power of parentheses 10 minus 8, and parentheses, and parentheses. So when I put this in, I get 0.121. Notice that I'm rounding to 3 decimals here. I think that's what the system asked for, but as always, make sure whatever the Cengage instructions are that you're following them. For number 3, my N is 5, NCR also 5, probability of success 0.9 to the 5th, probability of failure 1 minus 0.9 to the power of 5 minus 5. You might note 5 minus 5 is 0, anything to the 0th power is 1, so this whole part is just going to be equal to 1 and might as well not be there. If you recognize shortcuts like that, feel free to use them, but honestly, if you just follow the pattern, it's going to work out. And even though this is a little extra data that you wouldn't need to if you knew that this goes to 1, it really isn't going to hurt you to put it in. So if I put in 5 NCR, 5.9 to the power of 5, 1 minus 0.9 to the power of 5 minus 5. I get the answer of 0.59049, so I'm going to call it 0.590. In each of these cases, we're looking for a specific number of successes, so we could use the formula exactly once to get each of these answers. For questions 4 through 6, they ask us a greater than, a less than, a greater than or equal to, question that requires understanding the sample space and figuring out what exactly is involved in that question. So, probability of x is less than 2 when n equals 3. Well, if n equals 3, here's the set of everything that could happen. I could have 0 successes of the 3, I could have 1 success of the 3, I could have 2 successes of the 3, or I could have 3 successes of the 3. If I'm looking for which of these x's are less than 2, 2 is equal to 2 doesn't count, 3 is greater than 2 doesn't count. So the ones that count are 0 and 1. In order to find the probability x is less than 2, we're going to need to take the probability x equals 0 and add the probability x equals 1. The good news is that 4, 5, and 6 all refer to problems above. So if I look, problem 4 goes with problem 1 because we already calculated the probability that x equals 1. It was 0.189 for the same situation, n equals 3, p equals 0.7. So since I already have the probability of x equals 1, I'll just need to calculate the probability of x equals 0. That's going to be 3 NCR 0, 0.7 to the power of 0, 1 minus 0.7 to the power of 3 minus 0. So I need to go ahead and put that into my calculator. Really, I'm using a trick by pressing second enter to go back to things that I've already put in. There are ways to make this go quicker, but you shouldn't feel time constraints. You should have enough time to do this on the test. So when I do this, I get 0.027. That means in order to overall get the probability that x is less than 2, I need to take that 0.027, which represents x equals 0, add to that this 0.189, which represents when x equals 1. And when I take 0.027 plus 0.189, I get a total of 0.216. So the probability that x is less than 2 equals 0.216. Here, when I'm asked the probability x is greater than 7 when it's out of 10, my sample space would include my sample space starts at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I want the ones that are greater than 7. 7 is not greater than 7, but 8, 9, and 10 are. So to find the probability that x is greater than 7, I need the probability that x equals 8 plus the probability that x equals 9 plus the probability that x equals 10. Again, I mean these to go back to questions above. So here in question 2, you can see we already solved for the probability x equals 8. So what we're going to need to solve for is the p of x equals 9 and the p of x equals 10. When we do x equals 9, it's going to be 10 NCR 9, 0.6 to the power of 9, 1 minus 0.6 to the power of 10 minus 9. When we do x equals 10, it's going to be 10 NCR 10, 0.6 to the power of 10, 1 minus 0.6 to the power of 10 minus 10. After I get these two answers, I'm going to add them to this answer above, and that will tell me the overall total probability that x is greater than 7. So I'm going back and putting in first for 9. When I do that, I get 0.0403, which I'm just going to call 0.04. Then when I do the same thing for 10, I get 0.006. So when I add them all together, I'm going to take 0.121 plus 0.040 plus 0.006. That's going to give me 0.167, which is the overall probability that x is greater than 7. Last one, probability that x is greater than or equal to 4 when n equals 5. Again, I'm going to set up the sample space. I could have 0, 1, 2, 3, 4, or 5. In this case, greater than or equal to 4 does include 4 because of the equal to. So 4 and 5 are the things that are greater than or equal to 4. In problem 3, we already solved for when x equals 5. So when we do p of x is greater than or equal to 4, that equals p of x equals 4 plus p of x equals 5. The only new one we're going to need to do is p of x equals 4. P of x equals 4 is going to be based off of 5 NCR 4, 0.9 to the power of 4, 1 minus 0.9 to the power of 5 minus 4. So I go to put all that in my calculator. When I have it incorrectly, it tells me 0.328. So then solve for greater than or equal to 4. I'm going to take p of x equals 4, which I just found to be 0.328. I'm going to add it to p of x equals 5 that I found up here was 0.590. When I add those together, 0.328 plus 0.590, I get a total of 0.918.